Hello everyone, this is part 6 video on past year NEET questions from the chapter Thermodynamics in Physics. Now this is the last part video. Those who are looking at this can also take a look at the previous 5 parts so that you will have continuity of questions. We'll start with a question that has come in the year 1995. An ideal Carnot engine whose efficiency is 40% receives heat at 500 Kelvin. Means that is the source. If its efficiency is 50%, then the intake temperature for the same exhaust temperature is. So if you look at the Carnot's engine, right, we know that efficiency or efficiency factor will be related to what? The source and the sink temperature. So this is the typical design of the heat engine. So we'll take heat from the source, and by using that heat, some amount of work will be done. The remaining unused heat will be rejected to the sink. Generally, we'll indicate the source temperature as T1 and sink temperature as T2. So here, what is the thing? The initial efficiency is 40%, means efficiency factor will be what? 0.4. Final or second case, what is the efficiency? 50% means it will be 0.5. So initial efficiency factor 0.4 is equal to what? 1 minus, for the Carnot's engine, the efficiency factor will be 1 minus T2 by T1. Here the source temperature is given, which is what? 500 Kelvin. So which means 1 minus T2 by 500. Okay, so here the temperatures must be on the Kelvin scale. 0.4 means what? This is 2 by 5. 0.4 can be written as what? 2 by 5. Now what we have is 2 by 5 is equal to 1 minus T2 by 500. Okay, we'll rearrange it. So 2 by 5 minus 1 is equal to minus T2 by 500. So 2 by 5 minus 1 means it will be minus 3 by 5 is equal to minus T2 by 500. So minus minus is cancelled. 5 ones are, 5 hundreds are. We'll take the 100 to the left side. So 3 into 100 is what? 300. That is our T2. So that is the sink temperature. So what is the sink temperature? 300 Kelvin. Now in the second case, what we are doing, the exhaust or sink is as it is. The exhaust or sink is kept as it is. But we want to achieve the efficiency of 50% or efficiency factor of 0.5. Then what is the corresponding intake temperature? Means they're asking what is the corresponding source temperature. So here what will be the, in the second case, right? Second case, what are we going to have? The efficiency factor 0.5 is equal to what? 1 minus. So here the sink is as it is, not changing, means 300 will come. Divide by T1 dash. That is our new source temperature. Okay. So 0.5 means what? 1 by 2. 1 by 2 is equal to 1 minus 300 by T1 dash. We will bring the 1 to the left side. Half minus 1 means what? Minus half. Minus half is equal to minus 300 by T1 dash. Minus minus is cancelled. Cross multiply. T1 dash will be equal to what? 2 into 300, that is going to be 600 on the Kelvin scale. What is the intake temperature or the source temperature we should have for the same exhaust or for the same sink? If we want to achieve the efficiency of 0.5, efficiency factor of 0.5 means we should have the intake temperature to be 600 Kelvin, which is option C. So we have seen quite a number of questions based on the Carnot's engine and the heat engines. Okay. Next we have a question based on the adiabatic process. So if you see the entire set of questions, right, we got questions mostly repeated from where? From the adiabatic process, relation between the variables of the gas and the Carnot's engine and the refrigerator. So this is one more question based on the adiabatic process. In an adiabatic change, the pressure and temperature of the monoatomic gas. Monoatomic gas means what? Gamma will be equal to 5 by 3. So these gamma values you should keep in mind. Diatomic means gamma will be what? For a diatomic, gamma will be what? It will be 7 by 5. But here we are looking at only monoatomic, so we will require gamma to be equal to what? 5 by 3. So when you're looking at the relation between the parameters of the gas, this gamma will be important for us. So now look at it. They are saying the pressure and temperature related. What is the relation? P is proportional to T to the power of C. So in this we have to find what is the C value. See, if we look at the relation between the pressure and temperature in case of an adiabatic process, so we have three relations. What are the relations? Pressure volume relation, P into V power gamma will be constant. That is the pressure volume relation. Then T into V power gamma minus 1 will be constant. That is the temperature volume relation. Then we have P power 1 minus gamma into T power gamma will be constant. That is the relation between the pressure and temperature. This is what we are requiring here. So if you see this right, what we can conclude, P power 1 minus gamma. So just take the T power gamma to the other side. Will be equal to what? Some constant by T power gamma, means what? T power minus gamma into constant. Correct. So in the given relation, they are just saying P, means what? On both sides, take root of 1 minus gamma, means what? Both sides we have to raise the power by what? 1 by 1 minus gamma is equal to what? T power minus gamma into the constant. Power will be raised by what? 1 by 1 minus gamma. So here what is it? 1 by 1 minus gamma is cancelled. So what will have? P is equal to T power minus gamma by 1 minus gamma into constant power 1 by 1 minus gamma. So anyway, this is the constant. So what is the conclusion we can say here? Pressure is proportional to what? So I'll just erase the other part. So we got the relation. So what is the pressure? Pressure is proportional to what? T to the power of minus gamma by 1 minus gamma. So what is the relation? Pressure is proportional to T to the power of minus gamma by 1 minus gamma. Now we have to compare both these. What is the given expression? P proportional to T power C, right? What is the expression we got? It is what? P is proportional to, because there is a constant, means it is like what? P is proportional to T power minus gamma by 1 minus gamma, means what? We can say C is equal to what? Minus gamma by 1 minus gamma. So means what? C is equal to minus gamma is what? 5 by 3 divided by 1 minus 5 by 3. What is it? Minus 5 by 3 divided by 1 minus 5 by 3 means what? Minus 2 by 3. So minus minus is cancelled. 3 3 is cancelled. What is it? 5 by 2. So the value of C is what? It is nothing but 5 by 2. So correct answer is option D. So we are able to solve this question by comparing the given expression with the expression that we get from the relation between the gas properties in an adiabatic process. So those three relations, right? Pressure volume that we commonly see, then temperature volume, then pressure temperature. We have seen quite a number of questions asked on that. Next, a theoretical question. Which of the following is not a thermodynamical function? See, enthalpy, it represents what? Total heat content of a particular system. Gibbs free energy, it represents what? The available energy for doing useful work. You will study more about them in chemistry. Internal energy refers to what? It is the sum of energies of the particles of a system. Okay, so internal energy of an ideal gas means what? It is only related to the kinetic energy. Internal energy of the real gas means what? It will be depending upon the kinetic energy and the potential energy also, because between the real gas particles there will be interactions. When you talk about the work done, right? So this is a mechanical property, because you know, if you have a gas which is like this, so there is a gas in a cylinder which is having a movable piston. So when it is pushing the piston outwards, what is it? It's a mechanical property. It is not the thermodynamical property like the ones we have, the enthalpy or the Gibbs free energy or the internal energy. So what is the correct answer for this? They're asking which of them is not a thermodynamical function. Which is not a thermodynamical function? Work done is seen as what? It is seen as a mechanical property. Okay, because you know, there will be mechanical interaction between the system and the surroundings. Next we have a question based on the first law of thermodynamics. This has come in the year 1993. It's a straight question. 110 joules of heat is added to a gaseous system. Means what? The heat added, delta Q. Heat added means what? Positive, right? Will be what? 110 joules. Whose internal energy is changing by 40 joules. There is a typo here. The internal energy change is what? 40. Means what? Delta U is what? 40. Then the amount of the external work done is. So we need to find what is the amount of the external work done. So if you look at the first law of thermodynamics is what? Del Q minus W is equal to delta U. So here we rearrange means what we will get? Del Q minus delta U is equal to W. So del Q is what? 110. Delta U is what? 40. Both are in joules. So what is it? 110 minus 40 means it will be 70 joules. That is what is the work done. So the external work done by the system is what? 70 joules. Next we have another theoretical question. This is a kind of question which can be sometimes even challenged. Okay. What is this question? An ideal gas A and a real gas B have their volumes increased from V2 to V under isothermal conditions. Means what? You have on one side the ideal gas which is increasing its volume from V2 to V. Isothermal means temperature is same. Other side we have a real gas. Okay, which is also increasing the volume from V2 to V. Here also temperature is what? Constant. An ideal gas A and a real gas B have their volumes increased from where? V2 to V under isothermal conditions. The increase in internal energy. See, for an ideal gas, right, internal energy will be only what? Related to kinetic energy, which will depend upon the temperature. So temperature is remaining constant means what? The change in internal energy will be equal to 0 for what? The ideal gas. Whereas for a real gas, right? So this is the reason why I said this question kind of can be challenged. Real gas, the internal energy would mean both the kinetic energy part as well as the potential energy. Because real gas particles, there will be what? Interactions between the particles. They will have what? Potential energy. Now kinetic energy part, since the temperature is not changing, means what? The kinetic energy of the molecules will remain as it is. So the real gases internal energy, one part will be kinetic energy. That is not going to change. But there is the other part which is the potential energy part. Potential energy will depend upon the interaction between the particles. Potential energy is going to be depending upon interaction between the particles. In general, what would be happening is if the particles are going far away, they are moving farther, means what? The interactions will actually get minimal. Because if the separation is the separation between the particles is less, means what? They are closer, means we will see that there will be stronger interactions. But if they are far away, means what? Interactions are going to be minimal. So as a result, we are going to see some change in the potential energy part. But here if you look at the option that is given for this question, right, the option that they have given is the internal energy increase in both the cases A as well as B is given to be what? 0. So why this question could be challenged is because in case of real gases, internal energy is not only the kinetic energy of the gas particles, but also the potential energy has to be included. Okay, so that is the reason why this question could be challenged. But if you just look at the internal energy as represented by the kinetic energy, which is only for the ideal gas, by the way, since the temperature is constant, delta U will be what? 0. But real gas means there is going to be the potential energy part which would get changed. Why? Because it depends upon the relative distance between the particles. The interactions between the particles will depend upon the relative distance between the particles. Okay, so that is the reason why this question can be challenged based on whatever the answer that is given. Okay, so we'll move on to the next question. This is a question that has come in the year 1992. It's a straightforward question based on the cyclic process. A thermodynamic system is taken from state A to B along the ACB path. So A, C, B, and is brought back along the path BDA, cyclic, ACB and then BDA. The net work done during the complete cycle is given by the area. So already in one of the previous videos also we have talked about it. The work done in case of cyclic process, right, will be given by the area enclosed by the graph. What then is given by what? The area enclosed by the graph. So if you look at it, the first part, which is the AB part, or the other ACB path. In ACB path, what is happening? Volume is increasing, isn't it? So volume increasing means what? Work is done by the gas, so work done will be positive. So look at this. What is the area below that ACB? I'll just mark this with a plus symbol. All of them we'll just mark with a, so area below the graph you have to see. Area below the graph means what? The area below that ACB curve and the x-axis, which is the volume axis. Okay, so that entire thing that is marked as plus, right, that represents the area below that ACB. Then we have the other part of the cyclic process is what? The BDA. BDA, what is happening? Volume is decreasing. So in this case, W will be what? Negative. So look at it. Area below that means what? We'll put a minus. We'll put a minus. See one thing interesting. What is it? Whatever this plus and minus will just, when you add both of them, when you want to talk about total work done, right, the plus and minus will cancel. So total work done will be simply equal to what? The area which is enclosed by the A, C, B, D, A, total loop, A, C, B, D, A, that entire loop, right, whatever the area enclosed here, that is what is the work done. So here, if you look at this cyclic process, this is actually a clockwise. So in fact, in the discussion about the cyclic process question in one of the previous part videos, we talked about in a clockwise. Here if you see, the positive value will be higher, negative value will be lesser. So the overall work done will be what? Positive. If you look at an anti-clockwise, anti-clockwise means what? Look at this. It goes like this, anti-clockwise. We'll see that the upper part will be what? So we'll have an upper part and lower part. So upper part will be volume decrease, means negative. Lower part is positive. So overall, work done in case of that anti-clockwise will be what? Negative. In which case? In the anti-clockwise. So cyclic process, clockwise means what? Total work done is positive. In both the cases, the value is what? Area enclosed by that loop. But clockwise means work will be positive, anti-clockwise means work will be negative. So here they are not asking all these things, they are simply asking the work done during the complete cycle is given by the area. What is the area? It is the area enclosed by the loop A, C, B, D, A. So what is the correct answer for this? It is option C. The correct answer for this is what? Option C. So these things you have to keep in mind when we talk about the work done in a cyclic process. Next we have another question based on the CP-CV relation or the gamma relation. For a gas, R by CV is equal to 0.67. This gas is made up of molecules which are, by looking at this relation, we should comment on what is this gas made up of. So what is this? R by CV 0.67. 0.67 can be written as what? In terms of the fraction, it can be written as what? 2 by 3 approximately. Means what? Cross multiply. 3R by 2 is equal to CV. What is CV? 3R by 2. So if you remember the monoatomic, for a monoatomic gas, right, what is CV? 3R by 2 and CP is what? 5R by 2. So if you remember these values means we will be able to straight away conclude what is it? It's a monoatomic gas. Otherwise, from here you will try to calculate Cp by using the formula what? Cp is equal to Cv plus R. 3R by 2 plus R. What is it? 5R by 2. Now we'll take the gamma. Gamma is what? Cp by Cv, which in this case will be what? 5r by 2 divided by 3r by 2. That will be simply 5 by 3. Gamma 5 by 3 means what? Monoatomic. Okay. So either if you remember the Cp, Cv values, at least for the monoatomic and diatomic we remember means we will be able to answer these kind of questions if they come easily. Okay. Next we'll go to another question again based on the Cp-Cv relation. This has come in the year 1991. For hydrogen gas, Cp minus Cv is equal to A. And for oxygen gas, Cp minus Cv is equal to B. The relation between A and B. See here, they have not mentioned what is the Cp and what is the Cv. So we will go with the usual meaning. So these are the things that you need to be careful. Usual meaning means what? Cp is what? Molar specific heat capacity at constant pressure. Correct. Cv is what? Same thing. Molar specific heat capacity at constant volume. Now for any gas, Cp minus Cv will be equal to what? R. That is the relation that we have, whether the gas is a monoatomic or a diatomic or a triatomic. If you consider the behavior of the gases to be ideal, right? What is the relation? Cp minus Cv will be equal to what? R. So which means if we say for hydrogen, Cp minus Cv is equal to A, means what? A is nothing but R. For oxygen, we are saying Cp minus Cv is equal to B, which means B is also equal to what? R. So what is the relation between A and B? A will be equal to B. But they can even ask question on relating, maybe you can just try it out, check, relating the mass based specific heat capacities. Generally we will represent them by the small symbols, small Cp and small Cv, like that. In one of the previous question we have discussed about it. Okay, so small Cp will be equal to capital Cp by molar mass of the gas. Means mass based specific heat capacity of gas will be equal to what? Mole based specific heat capacity divided by molar mass. Similarly, small Cv is equal to what? Capital Cv by molar mass. Maybe you can check that problem also one more time, and we can expect maybe in future if you are looking at questions, means we can expect questions asked on relating these small Cp and small Cv values. Because for any gas what we know is the molar specific heat capacity Cp minus Cv will be R. But the small Cp and small Cv will be related in different way. Maybe you can check that question. I think in part 2 or part 3 video we discussed about it. So in future if there is a question, right, they can ask like relating between small Cp, small Cv of hydrogen to small Cp and small Cv of oxygen, like that. Instead of giving the molar specific heat capacities relation, they can ask a question on relating the mass based specific heat capacities. Okay. We'll go to the next question. This has come in the year 1990. 1 mole of an ideal gas requires 207 joules of heat to raise the temperature by 10 Kelvin when heated at constant pressure. Means what? This is our delta Q at constant pressure. What is the formula for that? It is N into Cp into delta T, right? If the same gas is heated at constant volume to raise the temperature by same 10 Kelvin, the heat required is, so remember they are asking us simply what? Delta Q in the constant volume process. What is it? NCV delta T. What is delta Q in the constant volume process? NCV delta T, correct. So here N into Cv means what? We can write Cp minus R, because Cp is equal to Cv plus R, right? Means Cv is what? Cp minus R into delta T. So delta Q at constant volume is equal to what? NCP delta T minus NR delta T. NCP delta T is that heat which is taken at the constant pressure, right? What is it? That is given as what? 207 joules. So 207 minus number of moles is 1. R is what? 8.3. So everything here is in the SA system. Everything here is given in what? In the SA system. Okay. So what is it that we have? We have this NCP Delta T is what? Heat absorbed at the constant pressure process. What is it? That is 207 joules as per the given data. Okay, so this is 207 joules minus number of moles is 1. R is what? 8.314, 8.3 approximately, but generally what is the R value? We'll take 8.314 joule per mole per Kelvin. Okay, so delta T is what? 10. So everything is in the SI system, so that also will be in what? Joule. So 207 joule minus 8.3 10 is what? 83. So 207 minus 83 will be what? It will be 124 joules. That is our delta Q at the constant volume process. That is what they are asking, right? What is the heat required at constant volume to raise the temperature of that same gas by 10 Kelvin? Correct answer is option D. Next we have another question based on the Cp and gamma radiation. 1990 this question has come. For a certain gas, the ratio of the specific heats is given by 1.5. Means what they are saying, gamma is equal to what? 1.5. So we have the relation for Cp and Cv in terms of gamma. Cp will be equal to what? R gamma by gamma minus 1. These relations are important. Cv will be equal to what? R by gamma minus 1. These relations basically come from the two equations. We have Cp minus Cv is equal to R and Cp by Cv is equal to gamma. From these two equations we will get them. What are those? Cp will be equal to what? R gamma by gamma minus 1. Cv will be what? R by gamma minus 1. Now look at it. Cp will be equal to what? R into gamma is what? 1.5, right? So 1.5 divided by gamma minus 1 means what? 1.5 minus 1, which is what? R into 1.5 means 3 by 2 divided by 1.5 minus 1 means what? Half. 2 is cancelled. What is it? 3R. That is Cp. What about Cv? R by 1.5 minus 1. That is what? R by 0.5 means it's like R by half. 2 will go to the numerator. That is what? 2R. So we have to look for the correct answer. So Cv, look at option A. Cv they are saying 3R. No, not correct. Option D, Cv 5R. No, means Cv is not matching. Then we have to check for whether Cp is matching. Cp is coming as what? 3R, right? Look at it. Where is it? Yes. Option B. Cp is what? 3R. This per joule is in terms of the unit. This per joule is in terms of the unit. Okay, so we'll just look at the value part. What is the value? It is what? 3R. Next we have a very basic and fundamental theoretical question. So this is in fact the last question that we are going to discuss. First law of thermodynamics is a consequence of conservation of. What is first law of thermodynamics? If you have a system, okay, it is in the initial state. We are supplying some heat. As a result of it, it will do some work and it will reach the final state. So the initial internal energy plus whatever the heat that we supply minus the work done by the system, that will be equal to what? The final internal energy. So if you take the ui to the right side, what we'll have? Del q minus w is equal to u final minus u initial. That is what? Delta u. So this is what is the first law of thermodynamics, right? What is it? It is simply a case of conservation of energy. So we're doing what? We're doing the conservation of energy. So correct answer for this is what? Option B. So with this we have concluded the discussion of past year questions from the chapter thermodynamics, and make sure that whatever the most prominent areas that have been touched upon, right? Like in this chapter, what do we have? We have questions mostly coming from the adiabatic process, relation between the gas properties, finding the final values if the initial values are given, and then heat engines and refrigerators. So this is about the thermodynamics chapter past year videos, and we'll see in the next chapter.